In this lecture, we're going to create an example application which makes real HTTP requests using the HTTP client library. And we are going to use just promises to handle the responses as well as the core functionality of our application. By the end of this lecture, you're going to have a brief understanding of what CORS is and how to temporarily bypass this security feature in your browser. You're going to know how to create an intermediate service to handle our HTTP requests to an API endpoint. You're going to know how to provide a service and consume it in our components. You're going to know how to convert the responses we get from our API into instances of a domain model. And you're going to know how to handle asynchronous work by using promises. In this lecture, we are going to create a mini application which lets us search iTunes for music. And we're going to be using this freely available iTunes API to perform the search. So if you scroll to the bottom of this page, here you can see instructions for how to use the iTunes API. But to use this API, we need to deal with a thorny issue called CORS. Now, CORS stands for Cross-Origin Resource Sharing. Now, this is a security measure implemented in all browsers that stops you from using an API in a potentially unsolicited way. And most APIs, including the iTunes API, are protected by it. And because of CORS, if we try to make a request to the iTunes API URL with the HTTP client library, the browser would issue a CORS error. Now, later on in this section, we're going to cover a proper solution to this problem, but for now, we need a way of switching off this security feature. Now, if you're using Chrome, I prefer to use a Chrome plugin, which lets us switch off CORS with a click of a button. Now, I'll provide this link in the description as well, but essentially you just go click this link in Chrome, and then the button on the top right-hand corner, just click it and it will install the plugin in your Chrome browser. And once it's installed, you'll see this button appear in your toolbar. When it's enabled and is active and is helping us bypass CORS, it's green. When it's red, it's switched off, so we want it green. Now, in our application, we have just a simple component. We have a search field and a search button. And whatever we type into the search field, and when we click search, I want to call the iTunes API and then render the results in a list underneath. So in our application, we have a very, very simple app component, which just has a constructor, an empty constructor for now, and the doSearch function. And in the doSearch function, we're passing in the search term. And then in our template, we have a simple form. We have the input field here. And we're using a template reference variable called search. And then when we click the button, we call doSearch and we pass in whatever the value is of the search input field. So far in this section, we've used the HTTP client library directly from the component by injecting it into the component's constructor. However, the recommended method is to create an intermediate service which uses the HTTP client library to make the request. And instead of returning raw JSON, the service converts the response into one or more concrete instances of classes, into something called a domain model. This makes it easier to test our component later on. We don't have to mock raw HTTP calls, but instead can define test data as instances of our domain model, which gets injected instead via a mock. More on that later in our section on testing. So we are going to create our own intermediate service, which I'm going to call search service. I'm going to add a property called API root, which will hold the root for our API. It's also going to have a results property, which is going to hold an array of objects. And it's also going to have a property called loading, which will be something that we use to show a loading indicator later on. And in our constructor, we're going to inject the HTTP client library and also store it on a private property called HTTP. And we're also initializing our results array to 0 and initializing the loading boolean to false. And I'm also creating a stub search function, which is the function we're going to call from our component when the user issues a search. Now, to make sure that Angular knows it has to inject the HTTP service into the constructor, we need to decorate our class with the injectable decorator. We also need to make sure we include it in our imports. And also, let's remember to provide our search service on our ng module. This will make it available for the entirety of the application. We don't need to provide it on individual app components. We can just imply it and provide it globally. Now, our search function, the search function on our search service, is going to make an asynchronous call using the HTTP client library to the iTunes API. Now, there are two ways we like to handle asynchronous functions in Angular. One is via promises and the other is via observables. In this lecture, we're going to solve this problem using promises, and in the next lecture, we'll solve the same problem using observables. And since we are using promises, we need the search function to return a promise. And if you remember from the section on ES6 and TypeScript, we can use promises, we can use our own promises by returning an instance of a promise class. And we put our main functionality in the body of the promise function here. The first, I'm going to generate the API URL, the full one. So I create a variable called API URL. I use the root of our API, which is this one here. The search API is the one we're going to use. And then I'm passing it some search terms. So I'm going to pass it the term that we're passing into the search function, and then some other parameters which are needed by the iTunes API. So we're going to search only for music, and we just want to limit to 20 responses. And then I'm going to make a GET request via the HTTP client library. So this.http.get, I pass in the URL. We want to use promises, so I'm going to convert this to a promise. But since toPromise is an observable operator, we need to include it. So I'm going to add that to our imports at the top. And since we're using a promise, we then use a then function, a then handler. And when the API responds, it calls the function we passed to then with a response object. And for now, I'm just printing out the response from the API to our console. So now we've created a basic search service. We need to inject it into our app component and make sure we call the search function on our service. So we've already provided search service on the ng module. So this means we can just inject it into the app components constructor. I'm just going to call it iTunes. And then in the doSearch function, we can just call iTunes.search and pass in the search term. So now if I rerun the application, let's look at the console. Let's clear it. I'm going to type in moo and press search. We can see some results have been printed out to the console. Let's have a look at the network requests. Scroll up a little bit. And this is the API request that we just made. So we're calling search. The term is moo. Media is equal to music and limit is equal to 20. Now this is working because we've switched off, or we're bypassing CORS. So just for a second, I'm going to clear this. I'm just going to show you what you would see if we weren't bypassing CORS. So this is normal. This is what you'd see normally in your browser. So if I press search, we'd see an error. So there's a couple of errors. The main one that you'll see is at the top. XML HTTP request cannot load, name of API. No access control allow origin header is present. So if you're seeing any errors to do with access control allow origin, you're probably seeing errors with CORS. So just double check that the plugin is installed and that it's switched on. So it's green. Once it's green, this API will work. Looking at the results object, or the response I should say, we are interested only in the results property. This results property is the actual list of search results from the API. So you can see here. But rather than return the search results to the component, let's instead store the results on the search service to make it easier to share the results between different components. And at the same time, let's add an error handler as well. So in our search service, let me put that down. Let's comment out that code. We store on our results property the results that were returned from the API. We also add an error handler at the bottom there. And then we also call the resolve and reject functions after we've finished processing the callback from iTunes, so that the calling function gets notified and can perform any post-processing if it needs to. So let's now render these results in our app component. And we are keeping the data on the iTunes on the search service, and to loop over them we use an ng-for directive. So if we go to the app component, just underneath, I'm just going to put horizontal rule to give us some nice space in between the form and the results. And then we're going to just have a list, so a UL. And then for each item in the list, we're going to use ng-for. And we're looping over iTunes.results. We're getting the track, and I'm just printing out the track name. So if we have a look at the actual results at the bottom, you see that the track name is what you probably would expect it to be. It's the name of the track. Now, if we rerun the application, I type in moo, we call the API, and there we go. Some results are being rendered on the screen. And that's looking okay, but we can do a little bit better. Let's use the Twitter Bootstrap list UI style and also show the track image and link to the track on iTunes as well. I'm just going to copy and paste this code in, but again, it's just standard Twitter Bootstrap HTML code. So we use something called a list group. That's just a normal list. It's just styled a little bit better. And for each LI element, we're showing an image, which is the track. I'm going to choose the artwork URL 30 pixels wide. And then we also have a link, which is going to be a link to the track view URL, which is actually just the link to iTunes. So now if we rerun our application, I search for moo again. And you can see we're seeing just much more nicely rendered results from the iTunes API. And if we click on one of these, you can see it's actually taking us to the specific page on iTunes. Okay, so now it looks like it's working, but to me, there's one feature which is really important when doing any asynchronous work, and that's to show a loading indicator to the end user, so they know the application is working and not broken. So let's show the text loading when we are still waiting for iTunes to return a response. So how I'm going to solve this is I'm first going to create a Boolean called loading on our app component. I'm going to default that to false. I'm going to set it to true when we issue a search. And then we also need to actually show something on the page when somebody's searching. So I'm just going to add just some simple text. So let me put it under the HR. So I'm just center aligning some text in a div. It's a p tag. Class lead is just the Twitter Bootstrap class to give it a slightly larger text. And I'm using an ng-if. So if loading is equal to true, we're going to show the text loading. So now if I rerun the application, let me search for moo again. And then you can see loading. It shows the loading text underneath. Now this kind of only half works because we have no way of setting loading to false again. So it's by setting loading to true, we show the loading message, and then we're not setting it to false again. And that's why we're still seeing the text loading. And we need to call some code when all the data has been returned by the iTunes API. Now the search service already returns a promise and calls resolve on that promise when this happens. And to hook into that, we add a then handler onto the return promise and set loading Boolean to false in there. So we add a then handler. And when the promise is resolved in the iTunes in the search service, the then handler will be called, and this will set the loading Boolean to false again. So now if I rerun the application, type moo, look carefully, loading is displayed, and then it's hidden again when the search results return. Let me try moo2. Loading is result. There's no search results right now for moo2. And maybe love. There we go. So we now have a functioning application. However, the format we are storing data in is just a plain JSON object. It's far better to parse our raw JSON data into instances of classes, into a domain model. So first, let's create a class called search item, which we can encapsulate all of the fields we are interested in. So we're just interested in 4 properties for now: name, artist, link, thumbnail, and we'll just put in the artist ID in there as well. And now in our search service, let's parse the JSON and store instances of search items instead. And a good method of achieving this is to use the map array function. Now this transforms each element in the array by passing it through another function. So we call map on the results. And this will loop through each of the results in here and pass it through this function, and only the result of passing it through this inner function will be stored on the results array. And what we do for each item in the results array is we instead drop the JSON and we return an instance of a search item with the JSON data that we're interested in initialized on our search item. And at the same time, let's be explicit and set the type of the results property in our search service to an array of search items. Like so. So now the results property is an array of search items, but also the names of the properties of our results have also changed. For instance, before we had track name and now we just have name. So we also need to update our template bindings to match. So it's now track.thumbnail. And it's now track name. And it's also track link. So now if we run our application one more time, let's search for love. And then we're now rendering out the data, but this time we're using instances of a domain model, of our search item domain model, instead of just using raw JSON. So we've now finished our application, our simple iTunes search application using promises. And to summarize, the recommended method to interact via a HTTP service is by creating an intermediate service which has the responsibility of communicating with the API. And then also storing the return data and converting the raw data into one or more domain models. In this lecture, we handled asynchronous code by using promises, by converting the observable return from the HTTP client library into a promise, and also by returning and resolving our own promise from our search service. In the next lecture, we'll look at how we can implement the same solution by using observables.